Vavilovian mimicry is a form of mimicry in plants where a weed comes to share one or more characteristics with a domesticated plant through generations of artificial selection. It is named after Nikolai Vavilov, a prominent Russian plant geneticist who identified the centers of origin of cultivated plants. Selection against the weed may occur by killing a young or adult weed, separating its seeds from those of the crop, or both. This has been done manually since Neolithic times, and in more recent years by agricultural machinery. Vavilovian mimicry is a good illustration of unintentional selection by humans. Although the human selective agents might be conscious of their impact on the local weed gene pool, such effects go against the goals of those growing crops. Weeders do not want to select weeds that are increasingly similar to the cultivated plant. Yet the only other option is to let the weeds grow and compete with crops for sunlight and nutrients. Similar situations include antibiotic resistance and, of similar nature to crop mimicry, herbicide resistance. This can be contrasted with other forms of artificial selection that tend toward a favorable outcome, such as selective breeding, having acquired many desirable qualities by being subjected to similar selective pressures. Vavilovian mimics may eventually be domesticated themselves. The Vavilov called these weeds become crops, secondary crops. Classification and comparisons. Vavilovian mimicry can be classified as reproductive, aggressive and, in the case of secondary crops, mutualistic. It is a form of disjunct mimicry with the model agreeable to the dupe. In disjunct mimicry complexes, three different species are involved as model, mimic and dupe, the weed mimicking a protected crop model, with humans as signal receivers. Vavilovian mimicry bears considerable similarity to Batesian mimicry in that the weed does not share the properties that give the model its protection, and both the model and the dupe are negatively affected by it. There are some key differences, though. In Batesian mimicry the model and signal receiver are enemies, whereas here the crop and its human growers are in a mutualistic relationship. The crop benefits from being dispersed and protected by people, despite being eaten by them. In fact, the crop's only protection relevant here is its usefulness to humans. Secondly, the weed is not eaten, but simply killed. The only motivation for killing the weed is its effect on crop yields. Farmers would prefer to have no weeds at all, but a predator would die if it had no prey to eat, even if they might be difficult to identify. Finally, there is no known equivalent of Vavilovian mimicry in ecosystems unaltered by humans. Delbert Wiens has argued that secondary crops cannot be classified as mimics, because they result from artificial as opposed to natural selection, and because the selective agent is a machine. On this first point, Georges Pasteur points out that indirect artificial selection is involuntary and thus no different from natural selection. That the signal receiver is an inanimate object certainly deviates from the normal case of a dupe perceiving the signal, but the result is no different from that of manual selection that has been occurring since the Neolithic revolution. Examples. One case of Vavilovian mimicry is the gold of pleasure of false flax, which looks much like the flax plant Linum usitatissimum, and occurs with it in the field. The gold of pleasure is a descendant of Camelina gabrata, a wild species. Its subspecific name linicola means the one that lives with flax. Weeding of the adult plant is impractical, instead they are separated based on properties of the seed. This is done by a winnowing machine, which in this case acts as an inanimate signal receiver. Seeds that are thrown the same distance as flax seeds have thus been selected for, making it near impossible to separate the seeds of these two species. Another example is rye, a grass which is derived from wild rye, a widely distributed Mediterranean species. Rye was originally just a weed growing with wheat and barley, but came under similar selective pressures to the crops. Like wheat, it came to have larger seeds and more rigid spindles to which the seeds are attached. However, wheat is an annual plant, while wild rye is a perennial. At the end of each growing season, wheat produces seeds, while wild rye does not, and is thus destroyed as the post-harvest soil is tilled. However, there are occasional mutants that set seed. These have been protected from destruction, and rye has thus evolved to become an annual plant. Rye is a hardier plant than wheat, surviving in harsher conditions, having become pre-adapted as a crop through wheat mimicry. Rye was then positioned to become a cultivated plant in areas where soil and climatic conditions favored its production, such as mountainous terrain. This fate is shared by its, which also tolerate poorer conditions, and like rye, grow as a weed alongside wheat and barley. Derived from a wild species, it has thus come to be a crop in its own right. Once again, paralleling wheat, rye and other cereals, oats have developed tough spindles which prevent seeds from easily dropping off, and other characters which also help in natural dispersal have become vestigial, including the awns which allow them to self-bury. The flax dodder is a creeper that grows around flax and linseed plants. Much like the other cases, its seeds have become larger. A mutant double-seeded variety has become prevalent, as seed size has once again been the character upon which selection has acted. Selection can also occur on the vegetative stage, through hand weeding. Weeding often takes place when the crop plant is very young and most vulnerable. Echinochlorrhizoids, a species of grass which is found as a weed in rice fields, looks similar to rice, and its seeds are often mixed in rice and difficult to separate. This close similarity was enhanced by the weeding process, which is a selective force that increases the similarity of the weed in each subsequent generation.